3. The explosive TNT has the molecular formula C7H5 and then NO2 quantity 3. How many elements make up this compound? Well, I have carbon, I have hydrogen, I have nitrogen, and I have oxygen. So I have 4 different elements. Not how much of each element, not how many atoms, it's how many elements, how many different elements. I have 4 different types of elements here. B, how many oxygen atoms are present in one molecule of this TNT? Well, we see that we have oxygen right here. There's a nitrite. Okay, we have NO2. Okay, NO2, you might think, okay, 2 oxygens. Well, that's not the case because we have these parentheses, this whole quantity. There's 3 of them. There's 3 of these. And so we're going to use the distributive property of multiplication and apply that 3 to the 2. And that's actually going to leave us with 6. There are 6 oxygen atoms. That 3 is multiplied by all the subscripts in that quantity. See, how many atoms in total are present in one molecule of TNT? Well, we have 7 carbon atoms. We have 5 hydrogen atoms. We have 3 nitrogen atoms. And then we already agreed that we have 6 oxygen atoms. If we add those up, looking at 21 atoms present in that molecule, just one molecule. Then we move on to D. How many atoms are present in a sample of 2.0 times 10 to the 23rd molecules of this substance? Now, you guys might think this is a scary problem to do, but it's not. We have a certain number of molecules of this substance. And we know that for every 1 molecule, there are 21 atoms, right? So I can even set up crosshairs to represent this calculation to make sure that I'm correct. For example, if I start with 2.0 times 10 to the 23rd molecules, and I know that for every 1 molecule, I have 21 atoms, I hope you can see that the units molecule will cancel out. And what will the unit I have left be? It'll be atoms. Now, I know this is a valuable conversion factor because I've already established that for 1 molecule, I have 21 atoms. So this is a statement of equality. This is just like multiplying by 1. So this is a legitimate thing to do. All I have left to do is do a little bit of multiplication. So let's see, what does that end up being? 42 times 10 to the 23rd. Okay. Now, this m value right here, not correct. Okay, not correct. It has to be between 1 and 10. So I'm going to move this decimal place over 1. So I'll be reporting a 4.2. But I moved the decimal point 1 to the left. So I'm going to have to change this exponent as well. So this becomes 4.2 times 10 to the 24th power. This is how many atoms are in a sample of 2.0 times 10 to the 23rd molecules of this substance.